Welcome to the SusCritMat short videos. We will now talk about the characterization of the urban mine. I'm now here with Armand Löwig. Armand is a researcher working at the Technology and Society Lab at EMPA. That's the Swiss Federal Laboratories for Material Science and Technology. His research is focused on anthropogenic metal cycles and recyclings. So, Armand, let's start with some definitions. What is the urban mine and what is urban mining?
So we use the term urban mine in a broad sense to refer to all the products and materials that are currently in use, stored, discarded or disposed. Basically all the things that surround us in daily life. The word urban is used to emphasize that most of these resources are located in cities. But when we use the term urban mine, we also consider materials and products in non-urban areas. A more precise but less catchy definition is anthropogenic resources. Urban mining, then, is the extraction of raw materials from the urban mine. And this is not a new activity. People have been recycling metals and glass for thousands of years. What is new today is that we are producing and using a lot of materials that are not really recycled at end of life. And this is a problem because, first of all, because of the high environmental impacts of primary production, but also because of risks related to the supply of these materials.
So why are many materials today not recycled?
Okay, so we have to remember that the urban mine is very different from traditional geogenic mines. So in the urban mine, resources are concentrated in particular products and components. For example, we have neodymium in magnets, or we have gallium in integrated circuits. And this is similar to how raw materials are concentrated in rocks and minerals in nature. But while in nature the resources are also concentrated spatially in certain areas, in the urban mine the raw materials are spatially very distributed. In addition to this, they are often much more complex than rocks and minerals. So they consist of a lot of different materials with different chemical and physical properties that are attached to each other in many different ways. So for these reasons, recycling is quite challenging, both from a technical perspective, but also from an economic perspective. Another important reason for the low recycling rates today is a lack of knowledge about the urban mine. Just like with geogenic mines, we need a lot of information before we start mining. So let's assume that you consider starting a business to recover gallium from end-of-life products. Unless you happen to also be the producer of products that contain a lot of gallium, you probably need to gather some information about which products it's used in, where in these products you can find it, how much gallium is contained in them, how many of them are being discarded and would be available for recycling, and so on. Probably you wouldn't even come up with the idea in the first place unless you already had access to some of this information. So the first step towards increased urban mining is to answer this kind of questions, or in other words, to characterize the physical system that constitutes the urban mine. Once we have an overview of the urban mine, we can identify candidate products and raw materials for which recycling can make a significant impact, and we can start thinking about how to ensure their recovery in a technically feasible way and also in a way that is economically profitable.
So how do you characterize the urban mine in practice?
So the difference in complexity between the urban mine and geogenic mines is about as big as the difference between an iPhone and a completely ordinary rock. Because of this complexity, a lot of the work that we do when we characterize the urban mine is to come up with useful abstract models that retain those features that are important for urban mining. For example, we use material flow analysis to create system models that we can then use to understand important connections between different processes in a product's life cycle and identify options for improvement. And we create classification systems for different products to put them into different categories before we start working with numbers. And this process of abstraction or simplification is the first step when we characterize the urban mine. The second step is to put numbers on it. And there is actually a lot of data existing. So, for example, every country has a central database with information about vehicles that are allowed to drive on its roads. There are very comprehensive statistics on international trade of goods or the production of goods within countries. And we have statistics on waste and many other types of data and statistics, of course. But most of these statistics and data were created for completely different purposes than characterizing the urban mine. And therefore, they often don't really match our needs. So on the one hand, we try to come up with useful systems to characterize the urban mine. On the other hand, we often have to make do with something that is less ideal. Another very difficult challenge when characterizing the urban mine is related to the composition of products. So we want to obtain preferably quite detailed information on what is inside particular products. You might think that this should be easy because certainly the manufacturers know what they put into their products. And while that is probably true to some extent that for any component or material there is an engineer somewhere who knows what is inside this component or material, this data is usually not collected in central databases, and it's almost never publicly accessible. So because of that, we often have to rely on data from sampling and analyzing wastes instead. And that has several disadvantages. So chemical analysis is expensive and time-consuming, and there are also no standardized methods that have been developed for analyzing complex waste materials. Usually the sample sizes that we can analyze are also very small, so they are not necessarily representative for societal stocks and flows. And most importantly, we are then restricted to analyzing waste products that have been in use for several, perhaps many years. And this is a problem because technology changes very fast, and what we find in the waste today is not the same as what we will find in 5 or 10 years from now. But the future is what we want to plan for, so that is a problem.
Okay, that sounds like there are lots of difficulties related to this urban mine characterization. So you have any outlook on how to overcome these hurdles?
Yeah, so now it sounds very difficult, of course. What is important to know is that there has been quite a lot of progress in the last years. So with the whole critical raw materials discussion, we have obtained, I think, a much better overview of many raw materials, of their use. And there have been several efforts to create harmonized data systems and to bring large amounts of information together in one place. There are also ongoing discussions about how official statistics and data collection can be improved for the purpose of urban mining. So I think this process of harmonization and creation of unified approaches has to continue, but it has to be done in a way that is flexible enough to deal with the changing composition and behavior of the urban mine. Finally, I think it's really essential that we get better access to data from manufacturers, or that this data reaches the people that need this information. Without this, we will always be a long step behind technological developments, and we will miss good opportunities for recovering critical metals.
Okay. Thank you very much, Amund, for giving us this summary and a short introduction in urban mining and the characterization of the urban mine.